Alrighty, so in this video we're going to start talking about calculating slope. We did that a little bit in the very first slope video that I made where it was more classifying slopes, and then we started to look at calculating it. We're not given a graph on this one, so we have to use the slope formula. So we're finding slope given 2 points on a line. So remember, points are always listed x then y. That's why we call them ordered pairs, because they're in order. First x, then y. X represents moving right and left. Y represents moving up and down, or down, I should say, or. We don't do both at the same time. So we have a point 1, so we note that with ones here. It's x of point 1, y of point 1. And then we have point 2, so x of point 2 and y of point 2. That's what the 1s and the 2s mean. It's just telling you which point is it coming from when it's kind of pushed down. It's denoting that point when it's lowered like this. It's not the same as having it an exponent that's lifted up. There's a different notation when it's lowered. This is part of the name, if you will, on that one. All right, so here's the slope formula. So remember, we're doing rise over run. And rise has to do with how far up or down did we go, and run has to do with how far left or right did we go. So to do that algebraically, to look at the numbers and figure that out, we're saying how far did I go from one point to the other in the y's, meaning up or down. So I'm going to take a look at the y points and I'm going to subtract them. So I have 3 and I have 9 for my y's. So I'm going to go 3 minus, remember that minus is already there. That doesn't change. Okay, that's not one of the numbers. That's part of the equation. So we have 3 minus 9. And that distinction of making sure that you understand it's part of the equation is important, because if you have two negatives in the middle, that turns into a positive. And we actually saw that happen on the last video. So we have 3 minus 9. So 3 minus 9, this is the same thing as saying 9 minus 3. And I know I've done this before in some of the videos where I'm using algebra tiles. So I'll kind of really quickly draw it off the side here. You go 1, 2, 3, 4, 5, 6, 7, 8. So they're not quite the same size there toward the end. I made it a little skinnier, but we have 9 negative tiles here. They all represent -1. And then I have +3. So 1, 2, 3. And when we're talking about algebra tiles, I can cross one negative to one positive off. They cancel each other out like this. So I can cross one off for each, and then I can look at what's left over. So this is another way of looking at adding and subtracting integers. So I end up with -6. This method will start to get a little bit more tedious as you get bigger numbers. So this one, definitely easy to draw. That only took me a few seconds. But if I'm having, numbers in, 10, 20, 30, hundreds, thousands, there's no way I'm going to be able to draw that. And it would honestly look very confusing with all of those tiles. So this just helps us see the visual for it, what's going on. But when I look at this and I have 3 minus 9, I can actually say 9 minus 3, and I get 6. Most students don't tend to get confused with that one. They know, okay, I have 9, I'm taking 3 away. But for the negative part, you just look at which number is more. Is 3 more or is 9 more? 9's more and it's negative. So my answer will be negative. Simply because I have more negatives than positives, which we can even see visually. There's 9 negatives, there's only 3 positives. I have more negatives. Okay? All right. So my next one, I'm going to look at the x coordinates here. So I have -3 and 5. So I have -3 minus blue 5. So this is not minus negative when I was talking about that just a second ago where this would become a positive. This means I have 3 negatives, so I would draw 3 negative algebra tiles, and I have another 5 negatives, so I draw another 5 negative algebra tiles, and I would combine them. So total I would have 8 negative algebra tiles. Okay. So on this one, what we want to do is reduce it. They can both divide by 2. This is also another situation of negative, negative. So this is a situation where it's going to turn into a positive. So we're going to have +6 over +8, and we're going to divide by 2. 6 divided by 2 gives me 3. 8 divided by 2 gives me 4. So make sure you reduce it so that Alex will accept that. Because that's definitely one, for this one, because I don't remember if I cut it off, usually it'll say simplify as much as possible, but if it doesn't say that, it may accept 6/8, and it will just give you a warning to, make sure you reduce your answer. But if it does say simplify your answer as much as possible, it'll mark it wrong if you try to do 6/8. So just a little quirkiness on Alex there. All right, so let's look at this other example. So we have a y of -3 and a y of -9. And remember, there is a minus here already. I'm going to put the minus there in the middle. So we'll go back to red here. So red. So we have -3 minus 9, because it's -3 and 9. And so this is that minus negative I was talking about. That's going to become a plus. So now I have 9 minus 3, and I get +6, because I can kind of do that backwards to help, organize that in my head instead of saying -3 plus 9. All right, and now we're going to do the bottom one. So I have -4 minus 8. So I don't put an extra negative in there unless the number is negative. So again, be careful about that one. So now I have 4 negatives, and if I want to picture that, I would draw 4 negative algebra tiles, and then I would draw 8 more negative algebra tiles. They're all negatives. So this would be -12. So now I want to reduce this. They can both divide by 2, but I could even go farther. They can actually both divide by 6. 6 divided by 6 is 1. -12 divided by 6 is -2. So this would be my slope, is 1/2. And Alex may want you to write it like this with the negative in front. It will still accept this, but it may give you a little error saying the negative should be kind of in the middle there. Because the negative could be on top, it could be on bottom, or it can be in the middle. All 3 of those are the same fraction, as long as there's only one negative. All right, we're going to look at finding the slope of a horizontal and or vertical line. So I have a little scenario off to the side here, and this is very small here. I'm going to zoom in just a little bit so we can kind of see these a little better, because that came out really small on my screen. So I have a little scenario here just to kind of help us remember these types of situations. So here's my example. We will order pizza for class. When it arrives, there are 0 pieces in the box. There's nothing in the box. And now, at the end of class, we have 5 pieces left. Does that make sense? How can we have pieces left if there was nothing to start with? Right? That doesn't make any sense. There were 0, now there's 5. Where did they come from? So this is a situation where I had nothing, and now I have something left over. It doesn't make any sense. I can't have something from nothing. And that's exactly what a fraction means. The number on the bottom is how many pieces make a whole. How many pieces did I start with total if I had the whole pizza? And the top number is how many pieces I've left over. Okay? So in this situation, it doesn't make any sense. I can't have something from nothing. So this is what we call undefined. And that's any time that we are dividing by 0. So if we end up having 0 in the bottom of our fraction, it's undefined. And this is an N, not an R. All right, so now let's read the second example. We're going to order pizza again for class. When it arrives, there are 10 pieces. Uh-oh, that was supposed to be a 10, darn it. I forgot to change that on my diagram there. There are 10 pieces in the box. So now we did have some pizza in the box. Yay, there's something there. And now we have 0 pieces left. So we have 0 left. Does this make sense? What happened to the 10 pieces? So what do we think happened to the 10 pieces? If there were 10 pieces and now there's none, well, hopefully we ate them all, right? That was the whole point of ordering pizza for class, so that everybody gets a piece of pizza. So this does make sense. I had 10 for the whole pizza when it got there, and then we all ate pizza, and now it's gone. I have 0 of the 10 left. This makes sense. So when we have 0 on top, when 0 is being divided, the slope is 0. Okay? So these are our 2 situations. We just want to make sure we understand why is it undefined and why is it 0. So now we're going to look at these 2 slopes. So we're going to have 8 and 9 and 8 and -6. So remember, rise are the y's. So I'm going to have 9 minus -6 for my y's. And I'm going to have 8 minus 8 for my run. So minus negative, that's going to turn into a plus. 9 plus 6 is 15. 8 minus 8 is 0. Uh-oh, that looks just like this one, doesn't it? I have 15 of nothing. So this is undefined. I can't do this one. Undefined. That one doesn't make any sense. Basically, it's a line that's going straight up and down because my x coordinates here are the same. So that's a way you can see it visually. It's a vertical line going straight up and down. On a coordinate, I can see that because the x coordinates will be exactly the same. All right, so now find the slope of a line passing through the points -4, 9 and 8, 9. So now my rise, I'm going to have 9 minus 9. And my run, I'm going to have -4 minus 8. So -4 minus 8. So 9 minus 9, that gets me 0. -4 minus 8, remember that's not the minus negative situation. Nothing turns to a positive there. I had 4 negative, I went 8 more negative, so I have -12. So now I have 0 of -12. Okay, so this is okay. I'm allowed to divide 0 by a number. As long as 0 is not on the bottom of the fraction, it's perfectly fine. So this is 0 slope. And this line would look horizontal like this. It's going from right to left because my y's are the same. So I can see the 9 and 9 are the same here. So that's how I can identify that visually on a graph because it's a horizontal line going right and left. There's no slope on it. It's 0. It's flat. And I can identify that in a point or coordinates because the y's will be the same. All right, so that was calculating slope and looking at undefined and 0 slopes as well. So go ahead and go on, Alex, and give that a try.